So this is the last set of notes for the semester. Don't cut anything out quite yet because we're going to do a couple of vocabulary words. But we're only going to have 2 pages today in our notes.
Yeah.
So,
Still recording already?
yes, it's recording. All right. We're on day 3 of Unit 5. And today we're talking about special linear types. Special linear types. What's the word linear mean? It's a line. So this is special types of lines, is what this is. Okay? They're extra special. And these are lines that you've learned already. You've learned these probably in elementary school, but you didn't learn the algebra definition. But I think they'll make sense to you based on what you learned in elementary school. So the first type are parallel lines. Y'all remember talking about parallel lines in elementary school and junior high? Okay, so parallel lines, most teachers talk about the railroad tracks, how they never cross each other, they just run exactly the same distance apart. So parallel lines are lines that have the same exact slope and never cross. They have the same exact slope and they never cross each other. Okay, that is a definition that you didn't get in elementary school because you weren't taught about slope yet. But if you kind of think about it, you probably understood in your head that they had to slant the same direction, the same way, right? Because in order for them to never cross, the angle of the line had to be exactly the same. So even though you didn't know what slope was, you still kind of probably knew in your head that the slant had to be exactly the same for that to happen. Okay, there is a symbol for parallel if you don't like to write the word because you're a true mathematician who's a little bit lazy, because math people don't really like to write words. You can use the symbol for parallel. Looks like that. So anytime you do that, it's like the 2 little lines kind of at an angle. You'll use that little symbol a lot in geometry next year. Okay, the other type. Anybody have a guess?
Straight.
No, not straight.
Horizontal.
No, starts with a P also. There we go. Perpendicular. Perpendicular lines. And I don't know if you remember perpendicular lines, but they are lines that cross at a perfect 90-degree right angle. So these are lines that cross at 90 degrees and have slopes that are completely opposite. And in parentheses underneath that, I want you to write the word flipped and change sign. Flipped and change the sign. And this will make more sense in just a minute. But their slopes are completely opposite of each other. In order for them to be perpendicular, the line has to go exactly the opposite direction. The opposite slant is the one that you start with. There's also a symbol for perpendicular, and it looks like an upside down capital T. Kind of like that. And some people put that little right angle thing right here, like that. I don't care if you put that there. If it's an upside down capital T, I know you're talking perpendicular. Okay, I need you guys to cut out. The graph at the top, where it says find the slope of each line, and then it says slope of line A, slope of line B, blah blah blah. Okay, so cut that part out. rest of that page. These lines so you can tell which ones are which, but you don't have to do that. I just like to kind of color code them so that you can see which one I'm talking about. Get those things glued down to this page. And before we get started, what do you guys notice about line A and line B? Just looking at the graph. They look parallel, right? Now, I don't know for sure that they're parallel, but they really do look parallel right there. So, we're going to find their slopes, and if their slopes match perfectly, you know they're parallel. That proves it. So to find the slope of a line from a graph, you're doing those little stair steps, rise over run. So go up and down and then sideways from one point to the next. So like on line A, the pink one, I do my little stair steps. Like that. I have to go up one and over 2 every single time, right? Y'all see that on line A? So my slope for line A is 1 over 2. I cut that weird, so I'm squeezing that in there. So 1 over 2 for line A. And that's a positive line, so I'm going to leave the slope positive. And then you're going to look at B. And if you do the stair steps there, it's also 1 over 2, and it's still positive. So that proves that those two lines are parallel to each other. Their slopes are exactly the same. That makes sense to y'all? It's an easy way to prove it. And I'm going to show you after we finish our notes how to look at it on the calculator and make sure. Okay, line C is kind of random. It's just leaning over here. It doesn't look like it's parallel to anything else. And it honestly doesn't look like it's perpendicular to anything else. But it does intersect. The word intersect means it crosses things. So C crosses D. It also crosses B and A. But it doesn't look like any of these angles are going to be 90-degree angles. Would y'all agree with that? Okay. So I don't think it's going to be the same slope as A or B. And I honestly don't think it's going to be completely opposite of A or B. So let's look what line C is. You're going to go up 2 and over 1, and it's positive. So if you look at line A and B, because they match, so we'll just look at B. B is 1 over 2. C is 2 over 1. So I did flip it, but did I switch the sign? No, the sign stayed the same. So in order for them to be perpendicular, you have to both flip it and change the sign. So if C was a negative 2 over 1, then it would be perpendicular to B. But since it's not negative, it's not perpendicular, it just intersects it. It's just kind of a weird one that intersects. But look at D. If you kind of look how D crosses A and B, can y'all see how it looks like that right there would be a right angle? Or this right here would be a right angle? Okay, so on D, it's going to be up 2 over 1, but that's a negative line. So that's a negative slope. which means the slope for B is flipped completely upside down. 1/2 became 2/1. This one's positive, so I switched it to negative. That one's negative. That means those two are perpendicular to each other.
Wait, so that means A and B are perpendicular?
A and B are parallel to each other, but A and D are perpendicular, yes. And so is B and D, since those two are the same slope. So I just kind of want you to see it from a graph perspective first. And then we're going to look at the equations and see if we can tell from the equations. So y'all have any questions on those four on the graph? How I found the slope or anything like that? Okay, look at these equations. They gave us sets of equations. They want us to say, is it parallel, is it perpendicular, or is it just intersecting? Because if it's not parallel and it's not perpendicular, they're intersecting lines. That's your only other option. So I need to look at what my slopes are. So on number 1, what's the slope on this first equation? Negative 1/2. So that's the number, this right here is the slope. What's the slope on the second equation? 2. So it's the same as 2/1. Are those exactly the same? No.
No.
So they can't be parallel because negative 1/2 and positive 2 don't match. Hey, what's up?
Can I borrow a few cents real quick?
Okay.
I don't know how to pronounce a lot of these.
Tanisha, Sarah, Shalea, and Lyric.
Thank you.
Need an extra one? I'll go.
Okay, y'all shut the door. Okay, so are those exactly the same slope? No. So they're not parallel. Are they completely opposite? Did I take this slope and flip it upside down?
Yes.
Yes. Did I change this slope from a negative to a positive?
Yes.
Yes. So that means they're completely opposite slopes, which means these two lines are perpendicular. If you don't want to write the word, you can just do the little T thing.
I define.
Because this slope and this slope are completely opposite of each other. 1/2 switches to 2/1. This one's negative, this one's positive. That makes them opposite of each other, so those are perpendicular. Okay, so look at the second set. What is this slope on the first equation? Here's this slope, here's this slope. So slope on number 2, the first equation, the slope is 3, or 3/1. The second one is negative 3/1. Are they exactly the same? Not exactly, because one's positive, one's negative. So they're not parallel, since they're not exactly the same. Okay, so are they flipped upside down?
No.
No, so they can't be perpendicular. What's your only other option? Intersecting is your only other option. So just put, you just do that. Intersecting. There's not technically a math symbol for that one. So you can just write intersecting for that one. Okay, last set. On number 3, they're trying to trick you because they're not putting the number in front of the x. What technically is always in front of x?
1.
A 1. So the slope for this top one is 1/7. The slope for the bottom one is also 1/7. They match perfectly. So they have to be, they match perfectly. They have to be parallel, right? The slant, the slope, the way it's leaning matches. This one's parallel. Or that symbol that looks like that. Okay, so you need the little table that was left out of your page of notes. Cut that out. You don't necessarily need the words at the top. It's just going to go at the top of the next page. Get that glue down at the top. Okay, we're just going to fill this in. So if it's parallel to the original line, what do you know about the slopes? Parallel lines have what kind of slopes? Exactly the same. So above that little column, write same. These slopes should match these slopes. That should be like the easiest column to fill out. If it's perpendicular, what do we know about the slopes?
Opposite.
Opposites. And not just opposite as far as negative, positive, but also flip. So flip and change sign. Flip and change sign. There you go. Sorry. So if I give you a slope of 2/3 and I need a parallel slope to that, it's going to be exactly the same. So it should be 2/3. If I give you a slope of -4 and I need a parallel slope to that, what should it be? -4. This first column, I mean, it's just a gimme. They're all exactly the same. A slope of -1/4, the parallel line is going to be -1/4. A slope of 2, the parallel line is going to be 2. A slope of -1/2, parallel would be -1/2. The slope of 7, parallel would be 7. Everybody understand that? Because that's the easy one. You don't really have to do anything to it. Okay, now if it's perpendicular, I have to flip it upside down and I have to change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. So what did you say? So it becomes 3/2 and it becomes negative. Yes. So you put 3/2
And 4.
and make it a negative. Okay, the next one's a little bit tricky because this is a whole number. How can I make that a fraction? Put 1 on the bottom. So this is right. This is the same as that. So now I can flip that upside down. So instead of -4/1, it becomes positive.
Can we just, so we can just put +4?
No, positive 1/4. So it becomes positive 1/4. So if it's a whole number here, you have to have a fraction here, like for the perpendicular. All right, -1/4, if I flip it, it becomes a positive 4/1 or just 4. What are we going to do to the 2? Put a 1 over it, I mean not over it, under it, and flip it so it becomes 1/2 and make it negative. See if you can do the last 2 by yourself. Don't say them out loud. Oh, wow. Let's see if I come through that wall. Okay, once you're finished, check them with mine, make sure they match. So make sure, if it's a whole number here, it becomes a fraction over here. If it's a fraction over here, and it's a 1 over something, a lot of times it becomes a whole number over here. Not always, but sometimes. Anybody have questions on that? Does that kind of make a little more sense of what's going on with parallel and perpendicular? Because here's what we're going to do with this. We're going to take these numbers, or this method, and you're going to write equations. Because they're going to give you an equation, and then they're going to say, I want a parallel equation to that. And I want that parallel equation to have this point on it. So for our first one, we're going to do y equals 5/2x minus 4. I'm kind of condensing the whole question down so that you don't have to write so much. But y equals 5/2x minus 4. We want to write a new equation that's parallel to that one, but through that point 2, 9. So it's gonna be a whole different equation than this one. And it's gonna have this point on it. If I need it parallel, what's the one thing you already know about that
They
equation?
gotta be the same. What
They've gotta be the same what?
No, well, the same slope.
Same slope. The slope has to match. So the slope here is 5/2, correct?
Yes.
So the new slope for the new line is also gonna be 5/2, because we're parallel. We're gonna write it. Okay, so, but you have to know, because if you're doing perpendicular, it'll be better if you write the slope here and then flip it and make it next, so you'll know what your slopes are. So when you do that, always write the original slope, the new slope. Okay, so you've got a point and you've got a slope. Is there maybe an equation that I've taught you guys that you could use with a point and a slope?
Minus y equal x.
It's that one. Do y'all know what it's called? Point slope form. Imagine that. Okay, so it's called point slope form because you're using a point and a slope. Here's what it looks like, just to refresh your memory. Y minus y1 equals m times x minus x1, like that. And we're going to fill in the blanks right here. This becomes a number, this becomes a number, this becomes a number. And the cool thing is, you've got those three numbers right there. Because with a point, the 2 is your x number, the 9 is your y number.
What is it called?
Point slope form. Point slope form. So you're going to rewrite that, and let's put the numbers in. So y minus, what's the y number of my point? 9. So we're going to do y minus 9 equals, what's the m number?
5/2.
5/2. X minus, what's the x number in my point? 2. So you're just filling in the blanks. No stress, no real big math involved, you're just putting the numbers where they go. Problem is, most of the time they're going to want it in a different form. What form do you think they're going to want it in?
Y equal mx plus
Y equals mx plus b is the most common. So they're going to want it in that form. What can I do to this to switch it around to that? Somebody other than Sarah. She's answering all these questions.
So
What would I do first to try to switch it to y equals mx plus b?
distribute.
Distribute, thank you. So we're going to pass out this 5/2 right here. So this side we're just going to leave alone. And then that becomes 5/2x minus, and remember I told you, you do 5 times 2, do the top one times the number, 5 times 2 is 10, and then divide by the bottom number. 10 divided by 2 is 5. Y'all remember doing that? Okay, it's almost there. We got this pesky minus 9 over here on this other side. How can I get minus 9 over there?
Wait, how did you get 5 again?
I did 5 times the 2, the top number times the big number, and then divide by the bottom number. 5 times 2 is 10, divided by 2 is 5. So if I'm going to move that pesky 9 over, it's being subtracted right now, so you're going to have to add it to get it to go the other side. Once you do that, you're home free. Negative 5 plus 9 is positive 4. So it looks kind of like the original, but what's different?
The point?
Yeah, it's subtracting 4 there and adding 4 here. So the b, the y-intercept number is different. This one, the original one, crosses at the negative 4 down here. The new one we wrote is the same exact slope, but crosses at positive 4 up there. Okay, so that's all you're doing. Don't worry, I'm going to do another one. We're going to do 2 more, actually.
So when you get this question, you give us the point.
Yes, you will have the point, and it will tell you whether it needs to be parallel or perpendicular. Okay, so let's try another one, just to make sure you got it. So if I have 2x plus y equals 6, and I need a new equation parallel through 5(1). 2x plus y equals 6, and we need it parallel through 5-1. Oh, not 5-1, 5, 1, sorry. first thing I need to know is I need to know slope from the original, but this isn't in a form where I can tell you the slope. So what do I need to fix?
Do you just flip the equation?
You don't
Put
flip
y
the whole
equals-
equation, but you need to switch it to y equals,
You put
yes.
y equals 2x plus 6.
Okay, but the 2x something needs to happen to it when it moves over. It becomes negative. It becomes negative 2x plus 6. Goodness. Time to record and everything in a row. Stephanie Rieper. Okay, good. Awesome. All right, bye. Okay, so you're going to move it over to make it y equals negative 2x plus 6. Like that. So now do you know what the slope is?
Negative 2x.
Negative 2, right? So this m is negative 2. So my new m should also be negative 2 because it's parallel. Once you have that, you ignore all of this first stuff. You just use this. Okay, because we're going to use that equation, that same equation, plug these in. This one will be easier because it's not a fraction. Okay, so we're ignoring our original, and we're just using this point slope equation. So y minus the y number. What's my y number?
1.
1 equals m number?
Negative 2.
Negative 2 times x minus
5.
5.
Yeah, we got it.
Okay, I need to switch it around to y equals, which means I need to distribute. So pass out a negative 2 here. This will be a whole lot easier since it's not a fraction. Y minus 1 equals negative 2x plus 10. And it's almost there. I just have that negative 1 right there to fix. So to move that minus 1 over,
You gotta add 1.
you're adding 1 to both sides. There's your new equation. Parallel. And you can tell they're parallel because here's my original. Negative 2x plus 6, negative 2x plus 11. So
Wait,
they
how
have
did you get 10?
How'd I get 10?
Yeah.
I did negative 2 times negative 5. I distributed. So they have the exact same slope, but they're crossing in different spots on the y. So like this first one crosses at 6, and then the next one crosses up a little higher at the 11. But they have the exact same slope. Actually, they would go the other way because they're negative, but whatever. My arm doesn't bend now. Okay, does that make sense? All right, let's do one that's perpendicular, and then we'll talk about the calculator. Okay, so number 3. Y equals 1/3 x minus 5. Hold on just a second. I'm going to fix this so that it doesn't have. I want it perpendicular through to negative 1. Perpendicular through 2, negative 1. Okay, so since it's perpendicular, this one throws a little bit of a kink in things because you can't just use the same exact slope. You got to fix the slope first. So this slope over here is 1/3, right?
So the other one is negative 3 over
Negative 3 over 1 or just negative 3. So your new slope, you're going to use as negative 3. Once you have that, you're done with this original equation. You're just using this original equation to figure out slope. That's all you're using it for. Once you've found that out, it's kind of tossed to the side. You don't worry about it. So now you're going to do point slope form using this slope and this point. So it's y minus the y numbers. If I do y minus a negative 1, do you remember what happens right there? It becomes
Yes,
plus,
yeah.
right? You're going to have to fix that in just a second. Equals negative 3 x minus 2. So I'm going to go ahead and fix this to make this y plus 1 over here. And then I'm going to distribute that negative 3. So we're going to take negative 3, multiply it times everything inside the parentheses. That's negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. 6. I've got one tiny little thing to fix. Subtract 1. Y equals negative 3x plus 5. Which means this equation and this original equation right here would be perpendicular to each other on the graph. And I'm going to show you that on your calculator here in just a sec. Okay, so that's kind of the stuff that your homework's over. But I want to show you some things on the calculator. So keep your journal out because we're going to go back to this in just a minute with the calculator, and I'm going to show you some things. You're not going to have to write anything else in it. But I just want to show you some things on the calculator. I'm going to use the one that I used last period. So first thing I need you to do is take your calculator and clear it. So second plus 712. And it should say RAM cleared. You guys, it is really important that you know how to clear the calculator, because when you're in a testing situation like the STAR EOC test, or if you take the ACT or the SAT test later on, or any of that kind of stuff, those people that are the adults that are in the room that are like monitoring are not allowed to tell you how to clear it. So if your calculator starts doing something wonky, you have to figure out how to fix it. They can't tell you the steps to clear it. You have to know how to use it. So that's a big thing. Because if you can clear it, it just like resets it all back to normal, to the beginning. You may have to start over on whatever it is you were working on, but at least it's not messed up. You know what I'm saying? So it's kind of like a factory reset. It kind of makes it go back to the original settings. So clear that. This little worksheet does tell you how to darken or lighten your screen. This is something that kids like to play with, but just so that you know, if you ever get your calculator and you push buttons and nothing happens, it's probably because they're darkening or lightening their screen. So do this just a second, and I bet it'll fix it. See if it'll work. So what you're going to do is you're going to hit second, and you hit the up button back and forth, like second up, second up, second up, and it'll get darker and darker and darker. See how my screen's like getting really dark? Or if you go second down, second down, second down, it'll get lighter and lighter and lighter. And if you go so far, it'll get so light that you can't see anything. So when you turn your calculator on, it looks like the battery's dead. And kids think that's hilarious. I don't know why. So they'll do that all the time because they're little punks. And they, oh, that's on the video. Anyway, but they lighten it up. And then some poor kid comes in and can't get anything on the calculator, and they think something's wrong with their calculator. Just darken it back up to probably about 6 or 7 is usually okay. Like it gives you a little number over there as you're doing it. 6 or 7 is usually dark enough. So however you like it, whichever spot you like the darkness level at, it's not really the brightness of the screen, it's just how dark the background is all it is. And whether your numbers and things that you push in the calculator are going to show up. Did that fix yours? I figured. Okay. All right, so if you ever get one that you think the batteries are dead, check that first, and then if it still doesn't work, then the batteries probably are dead. All right, so that tells you that. If you want to add to reduce fractions, and we've talked about this in class already, is math, enter, enter. So say you have some crazy fraction, 2,562 over 112, I don't know. And you're going to have to reduce that thing, and you don't want to have to figure it out by hand, because the only thing you know for sure goes into both of those is 2. And you know that you'll probably have to divide by 2 a bunch. You can hit math, enter, enter, and it'll reduce it down for you to 183 over 8. Okay, so that's handy, especially if you hate fractions. Math, enter, enter. It will not change it to a mixed number, but most of the time in algebra, you don't want a mixed number anyway. They'll leave it improper like that. So that's just a handy thing to do, and you can use fractions and stuff on the calculator, and it's fine. Like you could take that and times it by 7, and it will tell you what that is, and keep it a fraction, whatever. Okay, so that's just some of the stuff it'll do. We're going to do a lot in y equals today, and I think I've already shown you a little bit with this, but I want you to get really comfortable with it. because there's so much you can do on this, and it's a tool that you're allowed to use on your state testing. And so you aren't allowed to ask how to use the calculator during the testing, but it's a nice tool for you to have. And it will help you not have to burn so much brain power on those difficult questions so that you can, work on other questions. So hit y equals for me. It's the little gray button on the left, the top. And it should pop up a list kind of like this. Can y'all see mine okay?
Yes.
So we're going to type this equation in y equals. So you're going to hit 2, and then the x button is right beside the green button. It says x, comma, t, comma, theta, comma, n. That's called your variable button. So hit that button, it'll automatically put your x there. 2x and then minus 8. So you should have that in your calculator on y equals. 2x minus 8. Y'all see that?
Yes.
Everybody able to do that?
I can't find
You can't find which part?
The X.
The variable, it's right beside the green button. And there's some way that you can set it to where it says n instead of x, but there's really no reason for you to change it. It doesn't matter. As long as you know a variable is a variable is a variable. Whatever the symbol is doesn't really matter. Okay, we want to look at the graph. Because, let's face it, you have to graph these a lot, right? And so maybe you want to check and make sure you're doing them right. So hit graph. And it should draw the graph for you. There's one problem. Do you notice that your screen is a little longer horizontally than it is up and down? Like it's a rectangle, not a square, right? And if you look really closely, the little hash marks on the x are farther apart than the hash marks on the y. Can y'all tell that? That means that this graph is stretched a little bit. So it's not going to match your graphs on your papers. So you've got to zoom it so that it's good and square so that it'll match. So if you hit the zoom button in the middle little gray button that says zoom. Zoom square is the one you want. It's number 5. Zoom standard is the one that it automatically goes to. Zoom square is the one that's like all your graphs on all your homework, and it'll be on all your testing and all that kind of stuff. So square it up because, and I'm not going to show you. You don't have to do this. I graphed this line last period, the one we're looking at. If you have zoom square set up, you should almost be able to take your calculator and lay it right on top of the graph that you drew, and it should match. So if you look at those two, I mean, you can tell that angle is exactly right. Right? Can y'all tell that? Let me show you what happens if you don't zoom it. It's not a huge difference, but it's enough of a difference to kind of mess it up. So this is if you don't zoom 5. It looks really similar, but can you tell how this one looks like it's leaning a little more that way? Not a lot, but a little bit. And like this little triangle right here looks even, where if you look at my graph that I drew, it's obviously not even. Can y'all see that? Okay, so it's a little bit off, and it'll mess you up just a little bit. So always hit zoom 5. There's some cool things you can do when you're looking at the graph. One thing is, you know how they would give you an equation, and they would say, what's the output number if the input number is 10? And you'd have to plug it in and figure it out? Do y'all know what I'm talking about? Or what's the range number if the domain number is 10? Yes? No? Maybe? Do y'all remember any questions like that? Okay, if you'll hit second, the blue button, and trace, it gives you this whole list of things. We just want value, which is already on, so just hit enter. So second, trace, enter, and now it's blinking beside the X. Did y'all get that? Okay, second, trace, enter, and it's asking you, well, what X number do you want to put in? So let's put in 4. And hit enter, and it's going to tell you what Y number it is. Oh, looky there, 0.
0.
If I want to check another one, second, trace, enter, I can check -6. Whoops, that's 0.6. How about -6? Hit enter, that's -20. So any number you need to figure out, you can do it that way. To me, I mean, that's a cool way to do it if you're just doing one number and you're already on the graph. But I like to look at the table. To me, the table's easier because it gives all of them. So if I'm having to do 2 or 3, I'm going to use the table. How do you get to the table? Anybody know? Second
Oh,
graph.
second.
So hit second, the blue button, and the graph button. You've got a whole list of points.
Yeah,
Any point you need on that equation equation on that line is listed there. So if it says, what are 3 more points on this line, look up and down that table and find them. If it says, find the y-intercept, you know it's going to have a 0 for x, so 0, -8 is the y-intercept. How would you find the x-intercept? Y-intercept has a 0 for x, so x-intercept has a 0 for y. So find that one. 4, right? Y'all see that? 0 for y? Right there. So you should be able to look at this table and figure out any point on that line. And sometimes it gives you all kinds of decimals, and that's okay. Just stick with the whole numbers if you need to. Most of the time you won't need the decimal ones. Anything else on here that y'all really need to know how to do? I think that's about it. I want to go back to the word problems now. So keep your calculator out, but put that paper away. You can fold that paper and just stick it in your journal so that you have those instructions. Okay, I want to look at the parallel lines that we did, and I want to show you on the calculator how they look. So go back to y equals and hit clear, so clear out that one that's in there. And we're going to do this first one, which means I'm going to type this in the calculator, and then I'm going to type this in the calculator. Those two that I squared off in pink. So you're going to type 5 divided by 2x minus 4. 5 divided by 2x minus 4. Hit enter and it'll jump down to the next one. And then do 5 divided by 2x plus 4. Be careful, careful, careful that you put the x in there. Because if you get a straight line just straight across the graph, that means you forgot your x. If you get an error, you probably used the minus sign when you needed a negative, or the negative sign when you needed the minus. Because the calculator freaks out about that. Okay, so you get those two typed in. Once you have that, hit graph. And look at what those graphs look like. Because these are the two parallel lines we found. You should be able to check really fast on a calculator to see if you got your answers right. Do they look parallel? What do you think? Yeah, you can tell they're parallel, right? And if you wanted to see all the points on the line, you can hit second graph and it's going to give you a table with both lines. It's going to have x and then y for the first one and y for the second one. So it'll tell you like second graph. It tells you all the points. At 8 for x, the first line is 16, the second line is 24. So it'd be 8, 16 for the first line, 8, 24 for the second line. Okay, go back to y equals and clear those two. So you have to hit clear and then go down one and then hit clear. Let's do the perpendicular ones. So now type in that one and that one. 1/3 x minus 5 and negative 3x plus 5. One-third x minus 5, negative 3x plus 5. And then once you have it typed in, hit graph. It's going to draw them. And hopefully you can kind of tell that it looks like those cross at a perfect 90-degree angle. Can y'all see that? Okay, I want you to look at the table on this one. So hit second graph. If you're going up and down on the table here, where did I find it earlier? There it is. What do y'all notice at x equals 3 on the table? What's weird about x equals 3 that's different than all the rest?
-4.
They're both -4. Okay, these are perpendicular lines, so they're crossing each other. If they both have the point 3, -4, what does that mean?
Is that the point where they cross?
That is the point where they cross. Very good. The only point they can have in common is the one where they cross. Right? There's no other point that they could possibly have in common. But that point right there where they cross. So that 3, -4 is that point. And that's what you're going to start learning when we come back from Christmas break, is how to figure out the point where lines cross. But I just kind of wanted to show you that one because it was easy to see on the table. Like you can find where they cross. It's right there. The only one that matches. If you look up and down, as far as you can go, none of the other ones are going to match. Because those lines never curve back and go back across. So they're never going to match again. Okay, that's all the notes. You have about 10 minutes that you can work on assignment. And